Hey, hello, and welcome to the show. It's me, John Park, and you are here for a very special episode of Show and Tell. Actually, it's the same as all of them. They're all very special. I don't mean to single this one out. Thanks, everyone, for joining us over in the chat. If you're wondering how to join this Show and Tell, you can head over to the Adafruit blog, and you will see a post about getting into the StreamYard with a link. Or you can head over to our Discord, and there's a link in there as well. Our Discord is at adafruit.it/Discord. Jump over to the live broadcast chat channel and just click on that link. We'll add you in. Everyone will have an opportunity to spend a couple minutes talking about a project they're working on or something they're thinking of doing, a product they're excited about. Who knows? It's show and tell. There are very few limits within, the realm of tastefulness, I suppose. So what we're going to do is we're going to start out with some of our Adafruit folks and see what they're working on. And then we have some members of the community who are also going to be able to show us some of the things they're doing. Just remember to unmute your mic when I bring you on and spend a couple of minutes telling us what you're up to. I'm going to try to be out of here in about 25 minutes or so. So there's time for them to get set up for Ask an Engineer, which happens next. So here we go. Starting out first off, we have Noe.
Hello, JP. Thanks for picking me first. We're working on this together, so it makes sense, right?
Collaboration.
Right. Yeah, so you're working on like a Walkman-inspired kind of project, and you've already got a case going, but you wanted some of the snap fit goodness. So
yes,
I got all the parts modeled up here. So folks ever want these parts, you can always grab these off of our GitHub repo. So I want to shout that out.
Super helpful.
And this is a kind of a really challenging enclosure. There's three main pieces to it, and then a fourth one on the back here. So trying to figure out how to snap all these together is a little bit challenging with like no support material in mind, right? So here's kind of an X-ray view of it, and the way the display is going to get mounted is with just some screws and some kind of geometry that will hold it in place. And then what I have is we're going to use the doubler, right? So the feather doubler, it gives us all those lovely connections. So we're going to have the amplifier mounted to it. And then one of the things that you came up with is to extend the SD card is to have this SD card thing. I haven't modeled it yet, but I have it on order. And hopefully we'll get all that lined up nicely.
Yeah, it's just an extra long extension for a micro SD card, and so you can still kind of spring load in and out and get the SD cards, because we're using the SD cards like cassette tapes, essentially, like one album per, one mixtape per. So you want to be able to get at those, which is kind of buried deep inside there based on where the screen is.
Yeah, exactly. And then kind of this yellowish area here is going to house the two kind of inputs, right? The rotary encoder for doing some volume control, and then the audio jack. So that's just going to get mounted there. And then you have for like the play controls, like the media controls. We're using the Neo key, the 1x4 Neo key. So that gets mounted just with the keys, like the key switches just kind of get press fitted in there, and hopefully we won't need any standoffs for it. And then there's like all these slots and stuff. So let me see if I can highlight just this case piece here. So I'm kind of going with these like tabs that kind of are going to press fit into some of these lips into the other pieces. It's kind of hard to see, but that's sort of the idea there. And everything will print without any support. So there's still some more details to do. So we'll accentuate some of these seams here and probably do some decals and things. But
awesome.
That's kind of what we got going on. But another thing, if folks want these parts, check out our CAD parts repo on the GitHubs.
It is the most helpful thing in the world that you guys are always building these things as quality, accurate parts. Because when I did a mock-up of this little prototype for this, I had a minimal set of things that I actually needed to get out the calipers where I could just throw these actual parts together and align stuff and be confident it works. So it's incredibly helpful.
Thank you. That's the first thing I do. It's like, all right, do I have a model of this thing? And then just kind of toss all the parts into its own little folder.
Yeah.
Down there in the timeline, it's just a bunch of imports.
I also appreciate that you go about 100 steps beyond the minimum of just the shape of the thing and where the holes are, but you end up with accurate texture maps on there. And
Yeah, it's all thanks to the Eagle and Fusion integration. Like
that's great.
you can take Lamar's boards, open an Eagle, and just say, send it to Fusion 360, and it generates all those textures for you, so I don't have to do any of that stuff. So
Love it.
yeah, there's some layers on how to do that. If folks want to take the Eagle boards and bring it into Fusion. Check that out on our layer by layer playlist.
Well, thanks for working with me on this. I'm excited.
Yeah, totally.
We'll be seeing some prints as you go. And we'll do some revisions and things, and we'll be working on a guide for this in a few weeks, probably, once I've got software worked out and the circuit finalized, and you've got the case all juicy and ready to go. So
there will be cat explosions.
I was hoping there'd be cat explosions. That's great. Thanks, Noah.
I did. Peace.
We'll see you soon. All right. Let's see. Next up, we got Scott over here. Hey, Scott.
Hello. Hey, John. We'll see if my demo works. I just think I got it going.
Cool.
So what we have here is this is the landing page for CircuitPython. This is the web workflow, as I call it. So you can type circuitpython.local and you'll get a page like this. The device that responded here is this like USB OTG thing, but I also have 2 more on my network as well. And the device can find the other devices, which is cool. And I wanted to highlight here that this is the QT Py C3, which doesn't have native USB, but it's a pretty neat chip. So I wanted to click over to that, and we'll see if it works. So now you can see this is the home page for the C3. And it's looking for other devices. Maybe it's broken. But I wanted to show the serial terminal. It may not be working.
And so for context, this is
there we go.
Wi-Fi to the board.
Correct.
Serial.
Yeah. So here now we have the standard REPL. So this is over the network. This is over the Wi-Fi. And that didn't work. So there's clearly a bug here still. It disappeared. It's just really slow.
It's thinking about
I was trying to find out. And I made paste work. That's the other thing I wanted to show. So
nice.
Web workflow with the C3, I wanted to make sure that it was obvious that worked. And then I also wanted to show that in this code that I'm working on right now, I made paste work in here.
Excellent. That'll be hugely helpful.
I'm not sure why it's slow, so I'll take a look at that now.
Great. Thanks for the update on that.
Yeah, people should try it out. It's very neat.
Where should they go if they want to check it out?
It's in the absolute latest builds. We haven't done pre-release with it yet. And if you find issues, check there's now a web workflow label on our GitHub issues, so you can look there to see if it's already been reported. Thank you to Retired Wizard and Neradoc in particular for testing it for me.
Great.
Finding lots of issues.
Well, thank you so much.
Thanks, John.
We'll see you next time. Okay, next up, let's bring on Liz.
Hello. So recently I've been doing a lot of Microsoft Azure projects with CircuitPython, and so kind of the grand finale project is going to be a Raspberry Pi displaying multiple sensors on the screen. So today I started kind of laying the groundwork for that and getting Azure to talk to the Pi, since Pi is going to be receiving the data. So if I send a message to the device, I'll just do 4.5 and I send message, then the display IO updates. And this is actually using Foamy Guy's display IO Pygame library, which allows you to use display IO out on HDMI, which is really handy.
Nice.
So, yeah, so it can update the text pretty nice. I'll do another one. So this will be coming pretty soon. And another Azure guide went live yesterday, which is internet connected pet food scale. So folks can check that if they want more IoT.
Oh, yeah.
With this.
Excellent. Yeah, so that's one where you're doing our little load cell sensor, and
Yes, yeah.
you can remotely check on the pet food supply. Yeah.
Yes.
Excellent. Yeah. Oh, these are great. Well, thank you so much.
No problem. Have a good one.
Take care. Okay, let's see. Next up, we have Jeff. Jeff has
a keyboard
the
of
keyboard.
sorts. So I've been coming by for a couple of weeks talking about things with the QMK firmware and the KB2040. So, and other RP2040 keyboards. So tonight, the thing that I want to show, and I should mention that the guide about this is live on learn.adafruit.com. So check it out, and I'll leave some links in the Discord. This is showing that the QMK firmware can talk to OLED displays like this 128 by 32 monochrome OLED. And when you press the one button, rather than actually being a keyboard, it just goes through a couple of different demos. But that kind of sets the groundwork for customizing your keyboard with QMK and with KB2040 to show what you want on the screen. So my next project, just for me, is going to be to add the OLED to this 30-key keyboard so that it can show me. So this has like really not enough keys. And what you do is you use a key on the bottom layer and combine it with some other key to type like a symbol or a number. And I'm thinking that just if I get a reminder that, you know, this key is symbols and this key is numbers or whatever it is on the OLED, maybe I can actually learn to use it. So I'm going to do that for myself. But this is the example that works with KB2040 just as a pure demo. And there's a pull request that will add that to QMK that they're looking at right now whether to accept it. So yeah, but check out that guide if you are interested in keyboards with the RP2040. It really has come a long way this summer thanks to the QMK community.
That's great. Yeah, so I've looked at it and done just keyboard stuff and sort of some very simple configuration with the KB2040 and QMK in the past, but I don't think the display support was there until very recently, right? That's a...
You may be thinking of KMK, which is the one that's written in Python.
Yep.
This is QMK. It's written in C. They have different trade-offs. They're both really awesome projects with awesome communities. What's new is QMK supporting the RP2040 at all.
Right.
And we just want to show people how that works.
Cool. Yeah. Excellent. Well, thanks so much for sharing that, and thanks for the work on that. Looking forward to seeing you master the ridiculous Gherkin keyboard.
I think I'll stick with my regular.
I say that with fondness. It's a cutie pie, but it's ridiculous.
Yeah, we didn't do an example with the cutie pie, but the cutie pie RP2040 will also work. Like if you just have a keyboard with a few keys. Yeah, so lots of ideas in there. It's a great starting point. Teaches a little about customizing QMK. And yeah, that's what I got tonight.
Yeah, and for people who don't know, if you're doing sort of custom, semi-custom keyboard stuff, like getting a PCB that someone has made that's in a particular style you like, those very often, 9 times out of 10, use the Arduino Pro Micro form factor, which the KB2040 here is
a match for. Right, so that's why I was able to put it in. This is the Gherkin, which I've shown before, and it has a spot. I can't show it because it's hidden inside, but I can just solder on the more capable RP2040 instead of the original 8-bit version, the Pro Micros.
Right. Excellent. Exciting times for keyboard peeps. Thank you. See you.
Night.
Okay, let's see. Next up, we've got Matt P., who has been waiting in the wings here. Hey, Matt.
Hey, everyone. Can you hear me?
Yes, hear you well. What's new? What you got going on?
So this is like my chandelier project that I've been working on. I had to modify it because I had some issues translating range data on long wires. But basically, just like a chandelier, eventually going to be in my living room. And what happens is the current code is that I had to build it for a party. But the current code is that there's a rangefinder right here.
Oh, cool.
It starts going through some light cycles and some timing, and then it opens up and then just changes colors. So there's like a little timer in there and then like a range trigger. And eventually I'm going to design it to that the light, color, and the shape is going to be controlled by the rangefinder on the wall. But I had issues transmitting data over the long wires, so I had to modify it. But all the hardware is there. There's a jiggle in there that I cannot figure out how to get rid of.
Is that it's a lighting jiggle or a mechanical jiggle?
Mechanical jiggle. It's not an inertial thing. It's just I don't know. I had a massive debug list. I still couldn't figure it out, but it's a great project. And
oh, this is really cool. I mean, incredibly cool. What a great design you have there. Love that.
Yeah, thanks. It's been a great project.
What sort of hardware do you have for microcontroller, talking to motors, that sort of stuff?
Yeah, I got a Arduino Nano in the middle. I got 12 volts going to the LED strips. I got a 5-volt step down converter for the 6 servo motors. There's a Neo Pixel ring at the bottom. There's a sonar, Max Sonar Easy rangefinder that is mounted just below.
Mm-hmm.
And there's a giant line here to program it from the top. And
oh, that's great. Yeah, well, thanks for bringing it on, and we're excited to see updates as you go. So please come on back. It's looking amazing. Really cool project.
Thanks a lot.
Thanks, Matt. Take care.
Yep. See ya.
All right. Next up, we have Michael.
Hi. So I am working on a cool project. So I really love to use these like Adafruit TFT screens, and I want to utilize the ribbon connector, the iSi connector.
Yes.
So what I did was I actually made my own feather wing that has the little connector on it.
I want it.
And then not just that, I also designed and made a little a cutie pie BFB or BFF.
Great.
So here, I'll show this off on this camera here. So it's as easy as just plugging things in. Just plug this into here. Then this into there. And then power it up. And it should turn on. Yep, it turns on.
Absolutely fantastic.
There's one more thing I decided to do. So there were some unused pins. So what I did was I routed I2C for it.
Oh,
so nice. I designed my own stemma breakout. So it basically goes between, so this is the feather wing. And it literally just goes in between the screen.
Yeah.
So it still passes through the screen signals, but also allows you to connect like a temperature sensor or whatever sensor. So I have like a live demo here where it should show the temperature. And there we go.
This is fantastic. This would make my Walkman project so much easier because I'm having to do, so I've got one of those, I think it's identical to that, little 2-inch TFT that has that iSpy socket on there, and I'm just looking at it sadly right now as I hand wire like big dopey silicon 18 gauge wire all over the place. That's great.
Yeah, it's a great screen to prototype with. I've used it in other projects before.
Yeah.
So I'm like, I want an easy way to easily connect to it. So I designed my own thing.
That's great.
So I will be posting all the files, like so you can build it on yourself. So it'll be up on GitHub. But I just want to go through and these are prototypes, so I want to make sure it doesn't like break anything.
Sure. Yeah, that's great. I will look forward to that. Please post a link in the Discord because I will make a set of them immediately with rush order because that solves so many problems right there. That's
and
great.
It also has an on-off switch, which is in the convenient spot.
Yeah.
So it's like right above the power input, the USB port, so you can easily like, turn it on and off and still like reset it.
Yeah. So, and that's just running to the enable, to ground the enable pin?
Yep.
Yeah.
So,
spectacular. That
thanks.
Is a gift to humanity right there. Thank you so much for making that.
Thank you.
I'm excited. Great work, Michael. Thanks so much. We'll see you next time.
Thanks.
Did you tell I'm excited? I'm very excited. That was awesome. Last up, todbot.
Hey, surprise. Suddenly I'm on. All right. So I got two things to show. One is, you know how like there's all these little like tiny OLEDs that are out there that are usually pretty cheap. They're really great because like look at the great like wide angle visibility they have on them. Well, I found the Big Brother version. And so this is an OLED, and so it's got like the nice big big view angles, but it looks kind of like a VFD, like those old vacuum fluorescent displays from the 80s and 90s. And so I want to do something with this that's maybe synthy or maybe clocky. I don't know what.
Oh,
but
great. Yeah.
But yeah, so that's this, and it uses a standard SPI driver chip that is supported by CircuitPython. This is actually a CircuitPython program that's running here. The little hello that's bopping back and forth. So that's number one. The second thing is we all love the Raspberry Pi. And this is the Raspberry Pi, the Raspberry Pi Pico. But I hate that there's no pin labels, and so I made this little bit of plastic and label that sticks on top. That gives you back all your pin labels. And so it makes it really handy when you're wiring stuff up to say, okay, what's going to pin GPIO 14 or GPIO 15? So with like 10 with so with 10 minutes of 3D printing time and printing out a piece of paper with some tape, you too can have yourself a little label.
Can you show us the back side of the plastic side of it there?
Yeah, so it's got some holes. So maybe if the Pico gets hot, it'll be a little vent that. But also there's a little bit of a divot here for the boot button, so you can still press the boot button if you have it on.
Yeah.
And it doesn't attach permanently. It's just sort of like sticks on, but it sticks on, okay, and then you just take it off.
That's super. Love that. Yeah, I think I do. I haven't gotten. I know there's that breadboard that. Isn't there a breadboard that's kind of labeled Pico labeling?
Yeah, totally.
I always end up with an iPad or phone or computer, and I'm looking back and forth because
same. Yeah, and I always get off by one, because there's all those little ground pins stuck in the middle. Yeah. So yeah, it's like why?
I appreciate that they made the ground pins squared off and every other pin rounded. That at least gives you a sort of a waypoint as you're counting bumps of GPIO.
On one of the Picos, I got so fed up I actually soldered it upside down with the header pins just so I get the labels because labels are on there. They're on the back though, but of course that makes it hard to do the boot button.
Yeah. So. Oh my goodness. Okay, so many great projects this week that are here to make everyone's life easier. Between Michael's I Spy ribbon thing and this, everyone's going to have a better week. Love it. I'll tell you those sort of VFD looking OLEDs you have. Those totally look like they belong on a car dashboard. Like if you have Datsun or something that's cyberpunked out, you could.
No, totally. So the flickering is camera shutter speed. For some reason, my camera decided to change shutter speed on me. Who knows why?
Yeah, it was solid before. Changed its mind.
Who knows?
I bet if you hide that lamp with your head that's behind you, if you tilt to your own human left.
Human? What is this human you speak of? Anyway, I've taken up enough time.
Love it.
Thanks, man.
Cool stuff. Take care. All right. Thanks, everyone, for all the amazing things you brought on Show and Tell today. That was a lot of fun. And next up, there's going to be an Ask an Engineer, from what I understand. That'll be coming up in about 6 minutes or so. Please stop by for my workshop show tomorrow if you're around and have some free time. I'll be back up at 1 o'clock Pacific time, 4 o'clock Eastern time with John Park's workshop and showing some cool new stuff with flying faders. So that's the little tease for that. All right. Yeah. Thanks, everyone, so much for stopping by, and tune in next for Ask an Engineer. That was Show and Tell. Bye-bye.